Hello friends, I am Dr. Lokesh Desrai and in this video we are going to discuss how to compute one-way ANOVA in SPSS. So let us understand what is the purpose of one-way ANOVA. Analysis of variance or ANOVA is a parametric test procedure. ANOVA is used to compare more than two population means for a specific variables of interest. One-way ANOVA is used to test hypothesis where one dependent variable measured at continuous scale, that means interval or ratio, and one independent variable is categorical in nature with minimum three distinct levels or in few cases on ordinal scale. Why it is called one-way ANOVA? It is called one-way ANOVA because the analysis examines the effect of only one independent variable on a dependent variable. This single factor usually has three or more groups or categories whose means are compared. As you can see in the diagram, there are three groups of the population that represents three distinct categories of an independent variable, category 1, category 2 and category 3. And by applying one-way ANOVA, we are going to measure a significant difference in dependent variable among three distinct categories of independent variable. Now, the test statistics in one-way ANOVA is based on the variance calculation, the total variance in the sample due to the treatment effect and the random effect. The treatment effect measured between the samples, and this is the variance which is explained due to the factors, whereas the variance due to the random error is measured within the sample and it is unexplained variance due to the sample. Now, we can reduce the effect of this random error by applying randomization in one-way ANOVA. Now, there are few examples of one-way ANOVA. To examine whether customer satisfaction differs significantly among three smartphone brands, brand A, brand B, and brand C. In this case, the independent variable is smartphone brands with three distinct categories and dependent variable is customer satisfaction. To examine whether customer engagement differs across different social media platforms such as Instagram, Facebook, YouTube, and LinkedIn. In this case, the independent variable is social media platform with four categories and dependent variable is customer engagement. To analyze whether purchase intention differs based on different types of influencers, nano, micro, and macro influencers. So in this case, the independent variable is types of influencers with three categories and dependent variable is purchase intention. To determine whether employees' productivity differs across employee working in office, hybrid, and remote work modes. So in this case, the independent variable is mode of working with three categories and dependent variable is employees' productivity. So friends, in all the examples, we can see that the independent variable is having a distinct categories and dependent variable is based on continuous or numerical scale. Now, what are the assumptions of one-way ANOVA? The first assumption is fixed effect model. It means the result of the one-way ANOVA is limited up to the distinct categories of the independent variable which we have used in the experiment. Second is normal distributed population. Next is independent variable must be categorical or nominal scale. Dependent variable must be metric, interval or ratio scale, and there must be a homogeneity of variance in a dependent variable exist across the different categories of independent variable in the experiment. So these are the few assumptions which we are going to test before applying one-way ANOVA. Now let us understand the problem. The three different types of burgers, portobello mushroom, veg and black beans, were randomly distributed to three distinct groups of customers with 15 customers in each group. Total 45 customers. Each customer rated the taste preference in on 1 to 10 scale of the burger they received. Using the dataset Anova.sav, applying an appropriate statistical technique to examine whether there is a significant difference in the mean taste preference among the three types of burgers. So let us understand this problem. How many populations or treatment groups? So it is clearly revealed that there are three distinct group of populations. It means the group of customers and each group there are 15 customers involved. So we can say that there are three distinct treatment groups are there in this experiment. What treatment has been given? So a particular type of a burger acts as a treatment in this particular experiment. What is independent variable? So independent variable is a type of burger containing three distinct categories: portobello mushroom, veg, and black beans, whereas the dependent variable is based on rating scale, that is taste preference on 1 to 10 scale. How many sample means will be considered? Total 3 sample means will be considered, that is derived from three distinct group of the customers, those who will receive a particular type of the burger. And which test is applicable? Because we are measuring a taste preference for three distinct group of customers, so we are applying one-way ANOVA in this experiment. Now, what are the steps in the SPSS to solve the problem? The first one is you have to make data entry in SPSS as per the survey data or the problem given. Developing null and alternative hypothesis, you are required to examine two assumptions statistically. The first one is normality check by applying KS1 sample test and homogeneity of variance with Levin's test. Then post hoc analysis for pairwise comparison of the results, and then there are five interpretation which are required to mention: descriptive statistics for treatment groups, equality of variance, ANOVA test statistics, decision based on p-value and multiple comparison, and at last reporting the final results. Now we open the SPSS sheet. This is SPSS data sheet in which two variables are there: a type of burger having three categories: portobello mushroom burger, veg burger, and black beans burger. And second is taste preference on 1 to 10 scale. And this is a data sheet in which a first type of burger is distributed for 15 customers, a second type of burger again distributed the next 15 group of customers, and third burger is distributed to next 15 group of customers, and their taste preference measured on 1 to 10 scale, as you can see in this particular data sheet. So now the first step, this is a data entry, data view, and first step is we'll check the one sample KS test to check the normality. So again go to the data sheet and go to analyze, non-parametric test, Legosi dialog, and one sample KS test. The taste preference is the dependent variable. Transfer it to test variable list. Normal distributed, it is by default, it is selected. So press OK, and you can find this result. It is a normality test, and the p-value which we can find is 0.074. Now the decision on SPSS for hypothesis testing is based on the p-value. If the p-value less than 0.05 at 5% level of significance, then null hypothesis H naught is rejected. And if the p-value greater than 0.05 at 5% level of significance, then then your null hypothesis H naught is failed to reject, and decision will be in the favor of alternative hypothesis. Now, for one sample KS test, hypothesis for normal distribution test, we develop the following null and alternative hypothesis. H naught null hypothesis is the data follows a normal distribution, and alternative hypothesis data do not follow the normal distribution. The p-value is more than 0.05, that is 0.074 at 5% level of significance. Hence, we fail to reject or accept the null hypothesis and indicating the condition of normality. Thus, we conclude that the taste difference is normal distributed and can be used for ANOVA analysis. Now the step number 3 is we design the null and alternative hypothesis for the ANOVA test. So in this case, the H naught null hypothesis is there is no significant difference in the mean taste preference among the three types of burgers. Alternative hypothesis, there is a significant difference in the mean taste preference among the three types of burgers. Now we go to again data sheet and apply one-way ANOVA. So after checking the normality, we again go to the data sheet and we are going to apply one-way ANOVA. So go to compare means, one-way ANOVA. Taste preference is transferred to dependent list. Burger type considered as a factor, independent variable. Go to certain options, click on post hoc test, and we select the Tukey as a post hoc analysis that is used for multiple comparison. Continue. Go to option, select three option, descriptive statistics, homogeneity of variance and means plot, continue and press OK. So once you press OK, the following results appears on a output viewer window. The first table is descriptive statistics table. The second is test of homogeneity of variance. Third one is ANOVA. The next one is postdoc test result, multiple comparison, and then a means plot. So one by one, we make an interpretation of all these tables. These are the steps. Now, the first table is descriptive statistics. You can see in this table that the mean taste preference for portobello mushroom burger is 3, mean taste for veg burger is 6.13, and for black beans it is 5.87. This indicates that the veg burger has the highest average taste preference followed by black beans burger, while portobello mushroom burger is lowest preference among customers. However, descriptive statistics only show the average differences and do not confirm whether these differences are statistically significant or not. So we'll go to the ANOVA test statistics to verify this. The second is test of homogeneity of variance, Levin's test. So in this case, the null hypothesis is there is no significant difference in the variance of a taste preference among the three burgers group. Alternative hypothesis, there is a significant difference in the variance of taste preference among the three burger groups. So now you can see the significance value or the p-value is 0.738. Since p-value is greater than 0.05, the null hypothesis of equal variance is accepted. This indicates that the variance of the test preference across the three burger groups are equal, and therefore the assumption of homogeneity of variance is satisfied for conducting the ANOVA test. So in this case, we checked the two important assumptions. The first one is normality and second one is equality of variance. Now we go to the interpretation of ANOVA table. So null hypothesis for the ANOVA table is there is no significant difference in the mean taste preference among the three types of burgers, and alternative hypothesis is there is a significant difference in the mean taste preference among the three types of burgers. In this case, the F value is 10.835 with degree of freedom 2 and 42, and the P value is less than 0.05. So the null hypothesis is rejected and alternative hypothesis is accepted. This indicates that there is a statistically significant difference in the mean taste preference among the three burger types. And we can also explain the variance. The variance that between the group sum of square, it is 90.5, so which represent the variance in the taste preference due to the difference among the three types of burger, or it is called the treatment effect. Whereas the variance within the group sum of square is 175.467, which represents the variance in the taste preference within each burger groups due to the individual customer differences, and it is called the error variance or random error, and it is due to the random error effect. Now, since the between groups variance is large enough compared to within group variance, it results in a high F statistics 10.835, indicating that the burger type significantly influences the taste preference. So this is a result of ANOVA test, and this ANOVA table is based on this particular framework in which the source of variance between the sample within the sample degrees of freedom is k minus 1. So k is a number of groups, so total three groups will be there, so that is why k minus 1, it means it is 2, whereas n indicates total sample size. So in our case total sample size was 45, so 45 minus 3, it is 42, and n minus 1 is 44. So once we divide the sum of square with degrees of freedom, we'll get the mean sum of square, and once we make a ratio, a mean sum of square between the sample and within the sample, we can find the F statistics 10.835 and the p-value is less than 0.05. So the format of ANOVA table is based on this particular format. Now we come to the post hoc analysis. The purpose of the post hoc analysis is to use after ANOVA to identify which specific group differs from each other. It helps determine between which burger types the significant differences in taste preference exist in the experiment. So these are total three burgers are there. So total six combinations will be there. So first combination is Porbello mushroom burger with the veg burger. So we can see these p-values. So in this case, we can say that the Porbello mushroom burger versus veg burger, the mean difference is minus 3.133. P-value is less than 0.05. So significant difference exists. So it means customers prefer the veg burgers more. Similarly, the second pair is Porbello mushroom burger versus black beans burger. The mean difference is minus 2.86. P-value again less than 0.05. Again, it's a significant difference exists. It means the customers prefer black beans burger more. But in the third pair, that is veg burger versus black beans burger, the mean difference is 0.266 and the p-value is greater than 0.05, that is 0.932. It means no significant difference exists in the taste preference for this particular group. So the post-hoc analysis gives you a pairwise comparison between all possible pairs of independent categories in the experiment. Now, if we find the overall conclusion of this ANOVA results, we can see that the results of the ANOVA test shows that the significant value is less than 0.05. Therefore, the null hypothesis is rejected. This indicates that there is a significant difference in the mean taste preference among the three types of burgers. And based on the post-hoc test, it is found that the Porbello mushroom burger has a significantly lower taste preference compared to veg burger and black beans burger, while there is no significant difference between veg burger and black beans burger. Thus, customers generally prefer veg and black beans burger more than Porbello mushroom burger. And this is the means plot that indicating a difference in the means of a taste preference for these three distinct type of the burgers based on a single line chart. So I hope you understood the purpose of the ANOVA, the execution process, and all the interpretation. So thank you so much for watching this video and kindly subscribe the channel for more videos in this series. Thank you so much.